All right, help me out. We had two things that I confused Catherine with yesterday. It was talking about the Tesla Roadster and the Jeep Wrangler or something like that, right?
Yeah.
All right, so Wagoneer. So Tesla, we decided 1.1 seconds, and I forgot what the standard deviation was. I know, Jack, I know that's the wrong one. We verified it, but we'll stick with it. What was the standard deviation on the Tesla? 0.3 seconds. Okay. And this was going from 0 to 60 miles per hour. And then standard deviation's this. Okay, what was the Jeep? What did we decide? 7.9 slower. And then I made up the standard deviation. I said it was what? 3? Was that about right? All right. So we want to try and figure out, can the Jeep have a less time than the Tesla? And we kind of joked around saying you have a better chance of getting struck by lightning 15 times. Okay, so can the Jeep have a quicker 0 to 60 than the Tesla? And being the standard deviation is not that far out here, and it is far out here, because I mean, one standard deviation below in this situation takes us down to 4.9 seconds. A second one takes us down to 1.9. A third one takes us definitely in that range. So I want to figure out the combo mean. Combo mean is just basically 1.1 plus 7.9. So the combo mean is 9. Is that right? And then the combo standard deviation, this is where I need some help. Let's see. I need to know what 0.3 quantity squared plus 3 squared would be. I mean, I know mathematically this is 0.09 and this is 9. So I need the square root of 9.09. 3.01. Thank you. So this is the new standard deviation. This is the combo standard deviation. All right. So where should we go from there? Hang on, I gotta grab something. I'll be back. Don't run away again. All right. So, what is the chance that... So, if I want to know what is the chance that this happens, I'm going to do this. I'm going to go normal CDF. Normal CDF. And then, let's see. Let me make sure I do this right. Where am I getting that from? Oh. What is standard and mean standard deviation? Oh, I just lost train of thought. I'm sorry. So what is the chance? Oh, sweet. You know what? I did all this work towards this problem, and we don't even have this type of thing on the test. All right, cool.
Really?
Yeah, it's not going to be compared that hard. It will not be that difficult of a comparison. So that's pretty cool. All right. So let's, I want to lecture a little bit on the next chapter. It's 4.1. Well, this does have something to do with life because this is probability. All right, so I am on page 80. Page 80. And make sure you hey, take a look at yesterday's video, the day before's video for review. Make sure you have note cards all set up for that, for the test tomorrow. I'm going to try and get a larger number of graphing calculators to make sure we are set. But page 80, we're talking about 4-1, which is basic probability. So we've dealt with probabilities in so many things. We've all done something where we're trying to pick teams or randomly assign who's it or things like that. That's all basic probability. And if you were like me, you kind of counted out things going bubblegum in a dish. How many pieces do you wish? I've kind of been trying to figure those out when I was a kid to figure out how I wouldn't be it. You know, how many pieces I should pick. So yeah, that's kind of the nerd of stirrup. All right, probability at the foundation of statistical evidence. Before we reach the portion of our course that evaluates the quality of statistical analysis evidence, we need to learn some essential facts from probability. So probability of an event is, we'd probably say something like P at X, number of outcomes, of successful outcomes, over the total possible. Okay, so let's say we wanted to just talk about flip a coin. So we have heads and tails. Okay, so heads and tails. Do we all agree there's basically two outcomes that are going to occur? If you flip a coin, you grab it and you put it backwards on your hand, it's not going to be straight up and down. Agree? You know, your hand's going to force it to fall down if it so probability to flip a coin, probability of heads is 1 out of 2. Probability of going heads and heads is 1/2 times 1/2, which is 1/4. Okay. Probability of going heads is 1/2 times 1/2 times 1/2, so it's 1/8, so on and so forth. Okay, so there are chances that do take place with probability. There are certain events. Does the coin remember if it came up heads? No. Do the dice remember what was the last thing that showed up on the faces, on the topward faces? No. A lot of people think that there is a pattern to things, though using the whole idea of chaos theory, they say there is some sort of pattern to it, but finding that pattern, just walking up to an arbitrary table, I'm pretty sure you're not going to find that pattern. Okay. I have watched Jurassic Park, and
about chaos theory in Jurassic Park.
yeah, about a droplet of water rolling down one side of the hand versus the other.
It's a metaphor for dinosaurs.
The book was pretty good.
Water guns.
Yeah, sir, you should take part in Senior Assassin. That seems like something you would enjoy.
I should do what?
Senior Assassin. Where you
You
go
don't
around
know what
and
Senior
shoot people
Assassin
with
is?
water.
Is that where you guys squirt each other with guns?
Yeah.
Oh,
Yes. That seems like something you would enjoy.
okay.
Ow.
So, a single die, aka, dice. A single die. You have this as the outcomes. On a 6-sided die, normal, traditional, I realize there's ones that can be colors on sides, but single outcomes, if I want to know what the probability of rolling a 3 on a single die would be, there's one way to get a 3. There are 6 outcomes, so the probability of rolling a 3 is 1 in 6. Okay? The probability that I don't like this one. I'm not going to go there. Okay, so let's just go on to the set of dice. Let's go with a pair of dice. And this is, they have it all written out on dice on page 81. So that just shows all the different faces that show up. I like to do this way. That's all the outcomes on one die. This is all the outcomes on a second die. So if you roll dice, this would get a 2, a 3, a 4, a 5, a 6, or a 7. This would get a 3, 4, 5, 6, 7, or 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. Okay, so if you were to roll a pair of dice, there's one way you can roll a 2, there's one way you can roll a 12. You can roll a 1 and a 1, or you can roll in a 6 and a 6. Okay? These are all the different outcomes that take place. If you were to roll a 3, you could roll a 1 or a 2, or a 2 and a 1 on the different dice. Same thing with the 11, a 5 and a 6, or a 6 and a 5. 3 ways that you roll a 4. 3 ways you roll a 10. And if you keep going, 4 ways to roll a 5. 4 ways to roll a 9. 5 ways to roll a 6. 5 ways to roll an 8. And then 6 ways to roll a 7. Okay? So being you have all those outcomes, if you were to have a pair of dice, what is the probability you roll a 7? Well, there are 6 outcomes that are 7, and there are 36 outcomes of the dice. So then you have a 1 in 6 probability of rolling a 7 with a pair of dice. Okay? There's lots of different ways to go through dice. If you wanted to do the probability, I roll a 7 or an 11 on a single roll, and in the game of craps, if you have not established a point yet, if you roll a 7 or 11, you win if you bet $5, you would get $5, and you can pick up your other $5 and walk away with the table with $10 in your hand. So probability to roll on a 7 or an 11, well, a 7 are 6 outcomes, and 11 is, so I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 outcomes that are either a 7 or 11 out of the 36 outcomes. Reduce the fraction, so 2 goes into both. 2 goes into both. So we have a 2 in 9 probability of rolling a 7 or 11. Okay? But there's all different ways that you can use this table. It's pretty simple, where you're just going 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, so on and so forth, and walk through. And flipping ahead. Oh, okay. And then we get into the whole method of a deck of cards. Here's the sad thing, folks. Decks of cards are getting less and less and less realized of what they actually are. Because it's like, dude, why should I do that when I have my phone? So a deck of cards goes ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Yes, an ace counts as 1 and 11 in the game of blackjack. Ace is the low card when you're counting the decks, but you have to know that you have hearts, you have diamonds, you have, and those are your red cards, and then you have, and this is a standard 52 card deck. You have clubs, and you have spades. Okay. Of all of those, there's 52 total cards. There are 13 cards per suit. Okay, so ace or king is 13 cards. There are 26 red cards. There are 26 black cards. Okay, hearts and diamonds being the reds, clubs and spades being the blacks. And so, with all of that information, the probability that I grab a king out of a single deck of cards, if I shuffle them up, probability I lift a card and it's a king, there are 4 kings in the deck, 1 in each suit. There are 52 cards in the suit. Reduce the fraction, so you have a 1 in 13 probability that you would grab a king out of a deck of cards. Okay? What is the probability that I pick a king and it is red? 1 in 26? Yeah, so there's 2 red kings. So you get 1 in 26 probability of pulling that out. Okay? What's the probability that I select a diamond and a spade with 1 card pulled out? It's impossible. You're going to pull a card out. It could be a diamond or it could be a spade. It can't be both. Okay, what was the probability that I drew a 15 out of the deck of cards? Well, there's no 15s in the deck of cards, so it's a 0 out of 52. And or are important, and mandates both need to happen. Both events happen. Or means one or the other, and both can happen. Okay.
So how would you find out the or? So one of the questions on the homework is what's the probability of rolling a number greater than 2 or heads?
Okay.
A head, so how would that work?
Okay. Probability of what?
Rolling a number greater than 2. It's a
roll greater than 2.
Yeah, or
or
a head.
A head.
And then it's just 1 dice.
It's what, a single die?
Yeah, single die.
Okay. So the single die, the probability that I roll greater than 2 is a 3, 4, 5, 6.
Yeah.
So there's a 4 and 6 probability, or a head, which is a 1 and 2 probability. So let me see where we're at.
That's on the homework.
It's on the homework?
Yeah,
Oh, okay.
It's like 2C.
Gotcha. That's kind of funny that they have. Well, let's do this one first. Probability I roll greater than 2 and a head comes up.
Yeah, that's pretty.
Okay, so you're going to go 4 and 6, which can reduce times 1 over 2. So this is and, so I get a 4 in 12 chance, which is a 1/3 probability. Okay, so that's the and. The or, we have to think about this. Why did they throw an or in there on that homework already? Because I'm not even at the or on the. I know and or are important, but okay. Probably A or B, mutually exclusive. Oh, okay. So the probability I roll this or I roll ahead, I'm going to add. So then I have to make sure I get a common denominator. So multiply by 3 and by 3. So 4 over 6 plus 3 over 6. So 7 over 6, which kind of is goofy in this case. So the word or mandates any outcome in the sample which either or both events must occur. In example 9, probability selecting a king or a red or a king we're adding all the outcomes up. So in example 9, it says probability of selecting a red, that's 26, or a king. So let's look at that one first. Probability I get a red card or a king. Okay, so this is going to be the probability of red plus the probability of king minus the probability of red king. Because if you don't include the subtraction of this here, you're counting a card twice. So the probability of red is 26 out of 52. The probability it's a king is 4 out of 52. The probability it's a red king is 2 out of 52. So if we add this up, that's going to give me 30 minus 2, so it's 28 out of 52. And yes, you could reduce it to get you, what, 14 over 26, which is 7 over 13. Okay, so the or, you want to make sure you don't count something twice. So let's go back to what you said. Probability that it's greater than a 2. Or what? Head?
Or ahead.
Ahead. Okay, so these are two exclusive events. This mutually exclusive outcomes can never occur in the same trial. That helps highlight example 10. Diamond or spade. Okay, we already talked about that. I would say skip that one because it didn't talk about the or yet. We need to talk about, I think the book might have been off to what the notes were. With and for 3 probability. Yeah, let's skip that one for now.
The whole problem is
Just that C. Okay.
should we skip all of the ones that say or?
Skip the ones that say or for right now. Just because the notes didn't match up with the... I apologize. I did not proofread the book before I had it published. Yeah. Yeah, I'd say, which one are you looking at that had that?
So that's 2C, and then on the back, 5F and G. And
Yeah,
C.
I'd say skip any of the ones that say or.
Yeah, so 5B, C, F, and G.
All right, so the homework would be page 203, 204, and we're going to skip what?
2C,
2C,
5B, 5C,
5B,
yeah.
5B, get in a heart or a diamond. You can actually, 5B,
Yeah. And then 5C, F, and G, those all have O.
okay, being 2C, 2C I see, I could say yes. 5C getting, or 5 what?
So 5B,
5B, getting a heart or a diamond. A heart or a diamond is 26 different events out of 52. Okay, because they're not, the first one was flipping a coin and doing a dice thing. This one just has to do with a deck of cards. So you're not, it's okay to say, hey, what's the probability I get a heart or a diamond? You're talking about 13 cards that are hearts, 13 cards that are diamonds, so there's 26 outcomes out of the 52, so it's a 1/2 chance.
okay.
So that one would work with an or.
5, okay, what about 5C?
5,
The next one.
a king or a queen or a jack. Okay, we can still do that as well. You have a king, queen, jack in each of the suits, so you're talking about 12 cards. So 12 out of 52. And then
5F.
5F, getting a black or a red. That's all of them. So that's a 20 or
Yeah, that's a 50.
52 out of 52 or 1. Getting an ace or a diamond. An ace. So we have to remember this. If I have an ace, there are 4 aces in the deck. There's one of the aces that's a diamond. Okay? So there are 13 cards in a suit. So this is 5G. Oops, come on, 5G. So probability of getting an ace or a diamond. So you know there are 4 aces in the deck. I don't want to double count. Right now there are 13 diamonds where one of them is an ace. Okay? So I'm going to think about only the 12 diamonds in there because I don't want to double count that ace because there is a diamond ace in here. So this would be a 16 out of 52, whatever that reduces to. So those ors are, I think, are fine because you're talking about 2 of the same things you're dealing with. That one that was a heads or a, that's not going to make, that doesn't make sense to me right now to teach that. And this is funny. Question number 6 is my most watched video on YouTube. It's a ACT problem. And yeah, it's very similar to that sandwich one. But it's my most watched video on YouTube. It's like, I forget. It's minuscule compared to some of you guys on your following on stuff, but I'm like, it was funny because I get an email from YouTube saying, hey, do you want to start having videos? Let's see, is there a way to sort your, yeah, sort by most popular. My most popular video, it's problem 3 for ACT practice. It's a 2-minute and 20-second video in which I have 2.7 thousand views, so 2,700 views.
Is it monetized?
No.
That means it's helpful, sir. So that's good.
But what's funny is when I go to it, yeah, there's a video.
Would you want your students to have?
They have an ad that's attached to it.
This is about tutoring.
This one it had to do with salads, soups, and sandwiches, but it's very similar to.
Monetize it.
Huh?
Monetize it. You're already getting ads.
So should I be getting paid?
Yes.
Yeah. Most of you get paid for like reviews or something.
I didn't get any money.
Well, you need to.
You need to apply for it.
How do I apply for it?
Who knows? So there's a little, so your,
There's 4 comments on it.
What are the comments?
Let's see.
thank you, so helpful.
4 comments. So one says,
Watch one of them be a question that you just haven't answered for years.
You do a problem about this.
it looks like people are got mad at each other. Well, I can't see the very first comment for some reason. But the second comment says, well, that's not an option. The third comment says, thanks, Chris. And then the fourth comment says, see, that's what I thought, but the only answers to choose are 4, 14, 30, 120, 180, which...
So they must have been looking at an SAT scrapbook, and then they looked up how to do that type of problem, and then they
do your video.
And they blamed your video for not getting that. Like they tried to do the work for your video and didn't get the answer for it.
That's pretty funny. Okay. I even got a shirt and tie on in this video.
Wow.
Funny. All right.
Oh, are you not done?
I think I'm done. You guys know what the homework is, right?
Yeah.
That, skip 2C.
Who?